Lesson 4 in Chapter 1, Powers of Monomials. Don't forget, first of all, to put your key concept, power of a power, in your notes from the beginning of this lesson. We are being asked right off the bat to simplify, so remember we always have to keep in mind our instructions. First example is 8 to the 4th power in parentheses, and then all of that to the 3rd power. The way I'd like you to think of that to start off with is we have 8 to the 4th power times 8 to the 4th power times 8 to the 4th power. That's what the 3 is telling us here. And then we can use our laws of exponents to say that since we're multiplying these 3, we're going to add up these 3. That was our first step. So this would be 8 to the 4 plus 4 plus 4. But what I'd like you to eventually jump to is recognizing, because it's a power of a power, in this case, we're going to just say 4 times 3. The way I wrote it was 3 times 4. Let's make that 4 times 3. 4 times 3. And we get 8 to the 12th power, which of course is the same thing we had here, 8 to the 12th power. Let's do one more sample here. Example 2, k to the 7th power to the 5th power. So that's k to the 7 times 5, or k to the 35. Now you're probably thinking sometimes we are adding these exponents, sometimes we're subtracting exponents, and now sometimes we're multiplying exponents. How do I keep all these algorithms straight? And the key thing that I want to point out to you here is don't try to just memorize them. Don't just put them in your notes and try to apply them, because one day when you don't have your notes sitting there, or let's say you forget your notes at home on the day of the test or whatever, seek to understand. Don't memorize it, understand it. Think about this. You don't actually have to write out the k to the 7th. We have k to the 7th 1, 2, 3, 4, 5 times. If we had k to the 7th 5 times, that's k to the 7th plus 7 plus 7 plus 7 plus 7. You could look at it that way. Or you could look at it as that's k to the 7th, and I'm multiplying all those k's. Just imagine if we wrote this problem out, we would have k times k times k 7 times, and then another one, and another one, and another one, and another one. And if you just seek to understand that concept and think of it, picture it in your mind's eye, you don't really even have to write out all the nitty-gritty details of it. It's obvious that I have 7, 7, 7, 7, 7. I have k to the 7 times 5, k to the 35th power. That's how I want you to learn these, okay? Seek to understand. Please press pause and do letters A through C. Okay, once again, we have another key concept. Make sure the power of a product gets put in your notes so that you can refer to it later. Again, our instructions are to simplify. So in this case, the way I want you to see this is 4 times p to the 3rd power. If we were to write this out really longhand, we could put 4 times p times p times p, and then we'd have to do that same group 4 more times. So we can look at this way. It's 4 times p to the 3rd power, 1, 2, 3, 4 times. But we can look at this an easier way. We can take a look at this and say, well, that's 4 to the 4th power, because I can draw out this one factor here, 4 times p cubed. I can draw the 4 out. 4 to the 4th power would be 4 to the 4th power. P to the 3rd and then to the 4th power would be p to the 3 times 4. 4 to the 4th power is 16 times 16. 16 squared is 256. P to the 3 times 4 is p to the 12th power. Example number 4. We have negative 2 m to the 7th, n to the 6th, all of that to the 5th power. So we have negative 2 to the 5th power. We have m to the 7 times 5, and we have n to the 6 times 5, just like over here. Then we can just look at this and say negative 2 to the 5th power is negative 32. M to the 7 times 5 is m to the 35th. N to the 6 times 5 is n to the 30th. Try to get to the point where you can literally just look at this and go through the individual steps of math and go right to it. But always please write this intermediate step here to drive home that point of keeping track of when we multiply, when we add, when we subtract with exponents. Example number 5. The area of the logo given is 7a to the 4th b. And whenever we're calculating area, we recognize that because it's a square, we can just multiply side times side, or in this case we're just squaring it. So this is one way to look at it. Take this and square it, because remember, area equals s squared in a square. So it's squared. So we have 7 squared, a to the 4 times 2, b to the 1, remember this is implied 1 power, times 2. So we have 7 squared is 49, a to the 8th, b to the 2nd. Another way you could look at this, and this is the way I think most kids would look at it, because you'd forget that it's a square and you can just square it. You just say area is side times side. And if you look at it this way, then it becomes 7 times 7, 7 squared, a to the 4th times a to the 4th. In this case, because we're multiplying them this way, we're adding them 4 plus 4. And then b times b is b to the 1 plus 1. And we would still end up with the same answer, of course, 49, a to the 8th, b to the 2nd. And this is what I mean about trying to understand this. Some kids will see this problem this way, and you're using a little bit different rules than if you see it this way. Power of a power versus multiplication. Power of a power is just a little bit different than multiplying, but if you understand, you know exactly what you're doing. Seek to understand. Please don't memorize these. Do letters D through F, please. Here are our solutions to Chapter 1, Lesson 4, the letter problems. Our first problem, we're simplifying, is 2 to the 5th and then to the 2nd power. So that's 2 to the 5 times 2. Just imagine you have 2 to the 5th times 2 to the 5th. That would be 2 to the 10th power. And in a calculator, that's 1024. Letter B, we have w to the 4th times w to the 4th 6 times. So that's w to the 4 times 6. That's w to the 24th power. Letter C, in this case I did write it out here because this gets a little bit more complicated. We have 3 squared and then cubed and then all of that squared. So we have 3 squared cubed would be 3 squared times 3 squared times 3 squared, and then that quantity is squared again, so that's written again, so it would look like this. So then we could say 2 plus 2 plus 2, etc. Okay, so it'd be 2, 4, 6, 8, 10, 12, 3 to the 12th power. But what we would like to eventually do is get you to the point where you can look at this and say that, well, this is 3 squared times 3 squared times 3 squared 3 times. That's 3 to the 6th power times 2 is 3 to the 12th power. And 3 to the 12th, of course, from a calculator is 531,441. Letter D. We have 8b to the 9th power and then all of that squared. So we have 2 factors here, so we probably want to break it into 2 pieces. That's 8 squared times b to the 9 times 2. That would be b to the 18th. 8 squared is 64. So our answer is 64, b to the 18th power. Letter E. 6 x to the 5th, y to the 11th, all to the 4th power. 6 to the 4th power is our first part, 6 to the 4th. Then take the x's. X would be to the 5th power, and there's 4 of those, so it's x to the 5 times 4. And y to the 11th, again, it's to the 4th power, so it's y to the 11th times 4. 6 to the 4th would be like 36 times 36, which is 1,296. X to the 5 times 4 is x to the 20th, and y to the 11 times 4, y to the 44th. So take a look at this again. We could just say 6 to the 4th, 1,296, x to the 5 times 4, x to the 20th, y to the 11 times 4, y to the 44th. I do want you to write this intermediate step. Letter F. Negative 5w squared z to the 8th, all of that cubed. Negative 5 cubed is negative 125. W to the 2nd cubed is 2 times 3, which is w to the 6th. Z to the 8th power cubed is z to the 8 times 3, which is z to the 24th. Please press pause and do your guided practice. Here are your solutions to 1-4 guided practice. Problem number 1, we have 3 squared and then to the 5th power. So if we imagine 3 squared 5 times, that's 3 to the 2 times 5, that's 3 to the 10th. And 3 to the 10th is 59,049. Number 2, We have h to the 6th and then to the 4th. So if we imagine 4 of these h to the 6ths, we have h to the 6 times 4, or h to the 24th power. Number 3, we have 2 cubed, and then we have that squared, so 2 cubed times 2 cubed, and then we take that and we take 3 sets of those, so we have 2 to the 3 times 2 times 3. 3 times 2 times 3. 3 times 2 is 6, times 3 is 18, 2 to the 18th power, and that is 262,144. Number 4, we have 7w to the 7th power, all of that cubed. So we have 7 cubed, which is 343, times w to the 7 times 3, which is w to the 21st. 343w to the 21st power. Number 5, we have 5g to the 8th, k to the 12th, all of that to the 4th power, so it's 5 to the 4th, times g to the 8 times 4, times k to the 12 times 4. 5 times 5 is 25, and 2 of those, 25 times 25 is 625. G to the 32nd power, k to the 48th power. Number 6, we have negative 6r to the 5th, s to the 9th, all of that squared. So what you could do is just, because this is a fairly easy one squared, you could write this alongside of this and say negative 6 times negative 6 is 36. R to the 5th times r to the 5th is r to the 10th power, and s to the 9th times s to the 9th is s to the 18th power. Let it lay it out this way, or do it with the addition method where you have them side by side and then we're adding because we're multiplying rather than power over power. Problem number 7. We have a square, and they say that a side length is x squared y cubed in length. So we're going to find out the area. Area of a square is s squared. So we just take this monomial and square it. So it's x squared times y cubed, all squared. So that's x to the 2 times 2, y to the 3 times 2. That's x to the 4th, y to the 6th, and that's in square feet, of course. And lastly, our essential question. The answer to this essential question is like this. You can write power of a power as a multiplication problem with a common base, and then you can apply the product of power laws to simplify it. Please press pause and do independent practice.